Okay, part 2 of these word problems. They shouldn't be too bad, just be careful. Okay, a savings account earns 5.8% interest compounded continuously. So those are the words that we look for. So that's where we're going to use, and you will be given the formulas. We have our, this is going to be the formula A equals PE to the RT. So we have our PERT formula, and that's with continuous compound interest. A is your account balance, which is what we're trying to find. P is our principal. Our original investment is 5,000. E, of course, is our number. And our rate is 5.8, which is going to be 0.058 in 20 years. So it's going to be to the 20 power. So this one was pretty simple. A is approximately 15,949.6638. Again, with finance, we tend to round down, so 15,949.66. So $15,949.66. Okie doke. Next one, according to an advertisement in your collector's guide, a particular Star Trek trading card collection should increase in value at a fixed rate of 10% annually. So this is just our annual interest rate. This is not biology. It's not a biological one. So we have our, so this formula right here is not continuous. It's going to be A is equal to our principal and 1 plus r to just the regular t power. So that's if we're increasing. And then we also have a decreasing one. So this one is, it's increasing, so we're going to use 1 plus r. So this is going to be A is equal to 29.95 times 1 plus 0.10. Make sure you write it as a decimal to the 15th power. So how much is it equal to? It's equal to approximately 125, because you just put in the calculator, 0.1085. If we're talking about value, again, we tend to round down. It could be, I would accept 11 cents for this one though, because this one isn't just a regular investment. Okay. Next one, 30 years ago. So we have 30 years ago, 17 pounds of radioactive element buried in a toxic waste dump. The half-life of the element is 7 years. How much of that element is present today? That's going to be your half-life formula, the one that I'm giving you, because there are a couple. N times n sub 0, 1/2 to the t divided by t to t sub 1/2, so divided by the half-life. So we want to know how much element is present today. We know the initial amount is 17 pounds, 1/2. My time is 30 years. My half-life is 7. So n is approximately 0.8716 pounds. Make sure you write your units. The number of fruit flies in an experimental population grows exponentially at time 0. There are 20. After 5 days, there are 30% more fruit flies. How long will it take to have 200 fruit flies? So we want to know when it's equal to 200 fruit flies. We are missing our rate. This is in nature, so you are going to be using your n is equal to n sub 0 e to the kt power, and we are missing our rate. Sorry, we're missing our k. So in order to find our k, we know that there are 30% more fruit flies. So that's going to be 30% more is going to be 20 plus 30% of 20, which is going to be Sorry, thought I had that one written down. Okay, it was 26. Duh. Okay, so this is equal to 26. I don't know why. I could have done that in my head. All right, that's going to be the 30%. So we're going to use this 30% after 5 days to find our rate. So we have our 26 is equal to, our initial amount was 20. Doesn't seem right because I feel like I get a lot of fruit flies, don't you? E to the, I don't know what K is, but time in this case was 5. Now, we can do this, and you can find out what 20% of 30 is and add to 20. This is the same thing as 1.30. So that's 1 plus your 30% is 1.30. So first thing I'm going to do when you solve an exponential is you divide. And lo and behold, I have 1.30 is equal to e to the k times 5 power. How am I going to solve? I'm going to take the natural log of each side is equal to, I take the natural log of this side, I'm left with k times 5. So k is going to be approximately, well, I'm going to divide each side by 5. So it's going to be the natural log of 1.3 divided by 5. And I get 0.0524, or about 5.2%. Okay, now we want to know when there'll be 200 fruit flies, so we're going to use this calculation to figure out the rest of it. So for this here, now I know that this, but I'm actually going to be super accurate. I'm going to use this right here. I know we have our 200 is equal to, our starting amount was 20, E. Now I know K is the natural log of 1.3 over 5 times the T power. I divide by 20, divide by 20, 10 is equal to E times the natural, or E to the natural log of 1.3 over 5 times t. Take the natural log of each side. Natural log of 10 is equal to the natural log of 1.3 over 5 times t. I divide each side. Actually, you know what? I'm going to have you thinking about this a little bit. I'm going to multiply by the reciprocal, which is 5 over the natural log of 1.3. and 5 over the natural log of 1.3. So I have 5 times the natural log of 10 over the natural log of 1.3 is equal to t, and you put all that in the calculator. And you should get approximately 43.88, or t is approximately 44 years. Hopefully I put that in the calculator, all right. Yeah, okay. So I wanted to double check it. Okay, so that's that one. Buying a car, now we're not talking about, we're just compounded monthly, 4.9 annual percentage rate, and it's a 5-year loan. So we have we have two options here, and of course we have our $20,000 car. Option A, and again, this is where we're going to use our A is equal to P times 1 plus R over N to the N T power. Option A is our principal is 20,000. Then 1 plus my rate is 0.049. N is actually equal to 12 because it's compounded monthly. So be careful. To the 12 times 5 power, because there's our n again. So how much would you pay? You pay approximately 25,500. So this is going to be an interesting one. 25,500 and $39.69, because if you talk about a loan, they're going to tend to round up. Okay, but I take the 68 cents as well. So, but I know that's a weird one. Okay, and then we go to option B. They knock off $1,000. So instead, you're paying 19,000. Everything else is pretty much the same besides your rate, which is 0.0549 over 12 to the 12 times 5 power. Okay, I'm just checking my work here. To the 12 times 5. Okay, and I have 24,985. And 94 cents. Okay, I'm rounding up here because I would think that a bank would round up. Option B is better, even at the higher percentage rate. Sometimes that's a good way to go anyway. If you can make bigger payments, even though you have a higher annual percentage rate, sometimes they give you bigger discounts than this, where if you do it over the 5 years, this may be the better deal, but if you pay it off sooner, then this will be the better deal. So just life lessons from Miss Holly while we're doing a review. Okay. Number 27, using carbon dating to measure radioactive decay. Scientists can determine a fossil's age by how much carbon-14 is present. The half-life of carbon-14 is 5730. Recent deceased animal, 5 grams of carbon. How old is the fossil with 0.575 of the same animal? Okay. Sorry about that, guys. I know that it is ear piercing. That is Melody. Okay, we're going to use our half-life formula, which is our n is equal to n sub 0 1/2 to the t over t sub 1/2 power. I know that I want to know when we have 0.575 grams. Our initial amount is 5 grams. We have 1/2. My time, that's what we're trying to find. Okay, we're trying to find time, and we know the half-life is 5,730 years. Okay, so first thing we do is we divide, and we can leave that if it doesn't come out to be nice, but if I divide this is 0.115 is equal to 1/2 to the t over 5730. Now, since you don't have to do change of base formula with modern calculators, I really do think you should just do log base 1/2 of 0.115 is equal to, and then we have our log base 1/2 of 1/2 to the t over 5730. So the good thing about this is if we have this, then it's just going to be t over 5730 is equal to log base 1/2 of 0.115. I'm then going to multiply each side by 5730. And so this is 5730 times log base 1/2 of 0.115 is equal to t. And when you put all of that in, I got about 17,879 years or thereabouts. Okay, number of girls that participate in Girl Scouts and rural community. Don't worry about this too much unless you get an answer outside of your domain. Because this was within 12 years, they kind of forecast this. These number of girls participating in tease the time in years. How long will it take for the number of girls to fall to 150? So this is going to be 150 is equal to your 200 minus 70 log t plus 1. I don't know why this is coming out so weird. T plus 1. Okay, so I subtract 200, negative 50 is equal to negative 70 log t plus 1. Divide by 70, I have 5/7 is equal to log of t plus 1. This is an interesting one because remember this is log base 10. So anytime I have this is going to be 10 to the 5/7 power is equal to t plus 1 because we are rewriting it. I subtract 1. And this is what you're going to put in the calculator. T to the 5/7 minus 1, or 10 to the 5/7 minus 1 is equal to t. So t is approximately 4.1794 years. I'm going to say that t is just about 4.2 years. And that's my answer there. This one's a little interesting. Not too much work. So first off, it asks for the initial value. So we have m is equal to 160 e to the negative 0.02 times 0. M is equal to 160 e to the 0 power, which is 1. M is equal to 160 times 1. So m is equal to 160. When it has decayed to half its original size, our original size is 160, so half is 80. You can do the little nice trick where you just set it equal to 1/2 and don't worry about your initial amount, or you can write it like this. So it's 160, or sorry, is you could put 80 is equal to 160 e to the negative 0.02 t power. You divide, you end up with e to the negative 0.02 t is equal to 1/2, which we're familiar with. I told you guys you can kind of skip that. Take the natural log of 1/2 is equal to negative 0.02 t, because log base of the same number is just the exponent. Divide by negative 0.02, divide by negative 0.02, and t is approximately, put all of that in your calculator, 34.7 weeks. Let me know if you get something different, because that's what I've gotten twice. Last thing, salvage value, the number of years a piece of machinery, and a number of years n for a piece of machinery to depreciate. So we have number of years is n. Salvage value, you can use the formula where S is the salvage value, I is its initial value, D is the annual rate of depreciation. It says how many years will it take for a piece of machinery to decline in value from 90,000 to 10,000? So 90,000 is going to be your initial value, 10,000 is your salvage value, and we're being given the initial rate. So this is actually just a nice little substitution problem. Just has you thinking, that's all. Both of these are, so it's not that bad. So this is the log of 10,000 minus the log of 90,000 divided by the log of 1 minus 0.20. And if you just put that in a calculator, you get approximately 9.85 years. Okay, and then last but not least, it says how many years will it take for a piece of machinery to lose half its value? The annual rate of depreciation is 15%. So this is interesting, half of its value. So the relationship between, so here's our formula. We have log S minus log I over log 1 minus d. We know what d is. Well, the relationship between s and I is that s is equal to half of I. So I'm going to say, just for the sake of this, that, and I'm going to just leave a little space there for a minute. If I tell you that I is 1, then S is going to be 1/2. So it doesn't matter what numbers you have there. What matters is the depreciation, or is the losing half of value. Wow, I am so articulate today. Okay, 0.15. Okay. Now, if you remember right, like this would be the log of 1/2 divided by 1, which is the log of 1/2. And this right here would be the log of 10,000 divided by 90,000, because subtraction becomes division. And so that's actually also a way, because this right here, when I say it goes from 90 to 10,000, 10,000 is 11% of the original value, which this right here, just the 10,000 over 90,000, is equal to 11%. I don't know why I'm giving you a sidebar. I just wanted to kind of get you guys thinking, which you're probably not appreciative. So you just basically throw all of this in the calculator and you get about 4.265 years. We'll call this about 4.3 years just to make it easy. So there you go. Hopefully this went okay. Also make sure that you have those homeworks done, because those are also helpful. The review doesn't have everything. There are a couple questions that I'm hoping you practice on the homework in order to prepare you for your test. Just let me know if you have any specific questions, and hopefully you'll do great on this.